What if I told you that manually configuring IP addresses is wasting hours of your time? Imagine never having to set up another IP address, subnet mask, or default gateway again. In this video, I'll show you how DHCP automates your entire network, saving you time, preventing errors, and making your life as a network admin 10 times easier. Stick around to the end where I reveal the #1 DHCP mistake that could leave your devices offline. DHCP, Dynamic Host Configuration Protocol. The DHCP service allows devices on a network to automatically obtain IP addresses and other information from a DHCP server. This automates the assignment of IP addresses, subnet masks, default gateways, and other IP network settings. An internet service provider can either provide a static address to be configured on the internet-connected interface of its own router, or a dynamic address that will be distributed automatically by DHCP. On large networks where there are many users, DHCP is recommended. Thanks to DHCP, if new users arrive, or if there is a PC migration, the network admin will not have to manually configure the IP settings of the computer stations. They will be assigned automatically by the DHCP. If the ISP uses its own DHCP to provide an IP to the router's internet-side interface of its own LAN, then no manual configuration is required. The ISP's listed interface will be configured to function as a DHCP client. That is, the router will itself request an IP address from the internet service provider. And sometimes, the addresses are assigned by the provider statically, without DHCP. In this case, if the provider provides a static IP address without DHCP, you will have to configure it yourself on the router. Let's say the ISP assigns us the static IP 221.118.50.225 with a /27 mask. In this case, there will be two things to do. The first is to configure the static IP address on the router interface that is on the ISP's side. Here, it's the Giga00. And the second thing you need to do is to configure a default route that will forward all traffic destined for the internet to the interface that's on the other end of the router. That is to say, at the internet service provider. Managing a network can be time-consuming. Network users move regularly, new people arrive, and others leave. Each time users change or move, it requires work from the person who takes care of the IT. Depending on the number of users, manually configuring IP addresses on the network is virtually impossible. DHCP can greatly reduce this workload because it automatically assigns an IP address from a pool of IPs that it has defined. But it doesn't just do that, it also automates the configuration, subnet masks, default gateways, and also other network settings. DHCP is based on a client-server model. The server dynamically assigns IP addresses and parameters to clients. When we say client, it can be a PC, an IP phone, a printer, basically any end device that requests its own parameters from the DHCP server. Any device where it is possible to put an IP on it has the possibility to use DHCP to obtain its own IP configuration. In DHCP, there are 3 basic address allocation mechanisms. We have the dynamic assignment of IP addresses. This is the most common type of IP assignment. Let's take as an example the network of our home, with one PC connected to a Freebox router that does DHCP itself. As soon as the PC boots, the DHCP client service triggers a broadcast of the type DHCP Discover, which includes the MAC address of the client. If a DHCP server is listening on the same subnet, it will respond with a message such as DHCP offer. and as the name suggests, this message will offer an unused IP address from an address pool that is on the DHCP server. To accept the address that the server has proposed, the client will respond with a frame DHCP request. The server will then mark the IP address as being used in its database and send a message from ACK type to the client to confirm this assignment. Then the server starts its countdown. It is an address allocation timer. When this allocation time is over, the DHCP server can retrieve the address and send it back to its IP pool for later distribution to another host. The second mechanism is the automatic assignment of IP addresses. It is very similar to the dynamic assignment, except that the rental time, the lease timer, is set to never expire. This allows the DHCP client to always be associated with the same IP address. And we have the static assignment. This allows a host to remain reachable by an IP, which you will have previously chosen and statically configured in the DHCP database. This assignment is widely used on printers and servers, or any device that must remain reachable at a single address. A static entry is created in the DHCP database, which maps the IP address with the MAC address. This IP will then be removed from the DHCP pool. We have seen that an internet service provider can give a static IP to configure even on the interface of our router on the internet side. In other cases, an IP may be provided by DHCP. If the ISP uses DHCP to distribute an IP to our Giga00 interface, then no address can be configured manually. The interface connected to the internet will be configured to work as a DHCP client. The IP address DHCP command made on the egress interface allows it to make its own IP request to the provider.